You can hear me, right?
Can, doctor.
Okay. The link, is it can be accessed or not? Have you sign in the attendance? Can or not? Can sign in? Have you tried? Have
Yeah,
you
can sign in, can sign
can
in.
sign in? Okay. So we continue our lecture. Uh, okay. Let me share. Thursday how? According to the e-learning, you all want to have online class. Can you see my screen? Can I? The day we stop until here, right? I think today attendance will be very bad. Okay. To, the day we finish all this, right? This slide already finished, right? Okay, so these are all the key parameters to consider. Ah, what does this mean? Means when you want to choose, when you want to select a suitable underfill material, listen carefully. When you want to select a suitable underfill materials, let's say let's say you are given two supplier, okay? You are given two supplier, right? Okay, so normally the supplier will give you a list of properties, okay? A list of properties. So as a polymer engineer, materials engineers, so you must know so if the application is for underfill materials, so the key parameters that you must consider is this 1, 2, 3, 4, 5. It is 5 lah. The most important one, okay, is this 5. Okay. So if given for example chemical resistant, okay, the one is also important, but then it's not the top 5. Okay, it's not the one to you need to be prioritized. Okay, so for this application only, for underfill only. So first, flow is very important. Okay, so flow properties, from where you know which properties are important. So if given flow time or flow distance, or it is given rheology or is given viscosity. So that one, if given viscosity, so this you need to compare the viscosity between the supplier 1 and 2 lah. See which one is more suitable. Okay, other than viscosity, so there must be a set, a table, right? A set of properties. So other than flow properties, you must see thermal also. Okay, thermal like TG, gel time, and thermal expansion. So all these properties you must compare between supplier A and supplier B, and then you discuss why you choose that supplier. First, you need to choose one supplier. Okay, you need to choose one supplier. Then, after you have chosen, then you need to explain okay, why you choose that supplier from what aspect. Uh, what's your key parameters that guide you for the selection. So, so you need to discuss. So if given viscosity, then you compare. So the more properties you compare supplier A 1 and 2. Mechanical, you compare supplier 1 and 2. So if given ionic content, okay, if doesn't have ionic content, doesn't have environment, Then the next one, you know, right? Must be what? You see whatever you have, you need to judge, like thermal conductivity, the one. What is influencing your thermal conductivity? Or your heat dissipation. The one also is important. Okay? So you need to see the questions. If the question is 5 marks means at least you need to discuss 5 things. So you need to compare supplier 1 and supplier 2. So these are all the key parameters to help you, to guide you to be considered before you selecting and in underfill materials. Understand? You can get me? Can you get me? Yes, And okay, already 36, not bad. Okay, so this slide you understand, yeah? I already highlight the key one that you need to understand. Okay, so it's look like very complicated, but then it's very simple. Okay, so this slide is showing you all these parameters are influenced by all these factors. Okay, so maybe what's the another usage for this slide to guide you on how to select materials. Okay, if you're given like for example like 2 suppliers, many properties. This is the real situation when you become a materials engineer, then you need to make decision on what materials you need to select. Okay, so so you need to decide lah. So you need to judge. Okay, supplier A and B. Okay, like if I'm not mistaken, like your one of the assignment for your rubber processing also is like that, something like that. Okay, so you need to judge. Okay, in terms of flow properties. C is given. Is given what? The table is given what? Okay, so you know, right? Viscosity, rheology, and flow time, all these control your flow behavior. Okay, your gel time, Tg, and your thermal expansion, the one is controlled by your thermal properties. Or one more is thermal stability or dimension stability. These are all thermal properties. It's important also. Okay, so you must select the most important thing, the most important one to discuss. Okay, for example, 5 marks. You don't put the not important one. Okay, at the top. You put the most important one at the top. First, second, third, fourth, and fifth. Understand? So you need to judge which one is very important. Flow, you see, flow is very important. And thermal is very important. And come with mechanical. So of course, flow, you have many parameters that can influence your flow. And thermal also, you have many parameters that influencing your thermal properties. And mechanical also, you have strength, you have toughness, you have modulus. Okay, so all are under mechanical. Okay, so normally these two are less important because all top 5 will be inside these 3 category already lah. Okay, the thermal properties including the thermal conductivity also, right? Okay, you need to judge. Okay, this one I cannot teach you. You need to see which one prioritize first. Okay, so underfill is what? Is a liquid. So underfill before cure is a liquid. So flow very important because it's liquid. You need to fully flow underneath between the chip and the substrate. Correct or not? Okay. So secondly, when it's cure already for application, thermal, mechanical is very important. So you need to judge by yourself. Understand or not? Who cannot understand? Open your mic. I explain again. Or put up your hand. Who cannot understand? Who cannot follow? Can follow, Okay, I can tell you this is important. Okay, so we move on. Okay, properties of underfill materials. Okay, when we talk about properties, So you before this you have learned all the testing and characterization, right? You have learned many. You have learned mechanical, you have learned thermal. Under mechanical also many. You have learned tensile, fractural, impact strength, impact toughness. Okay. Okay, so you have learned many. Okay, so for underfield, so you know underfield is thermoset. Okay, underfield is thermoset. So I will based on this application, because our subject is for electronic application. So based on this application, what are the properties are important to be studied lah? Okay, so I select the one you seldom come across. Okay, I said, for example, I said anything. I said siapa dengan Aizat? Anyone with Aizat? Anyone with Aizat? No, he is alone. Dia sudah mengantuk kok. Kepala sudah kepala sudah sentuh dia punya keyboard, lepas tu sudah raise hand. Lepas tu dia sudah tertidur ke? Dia raise hand for non sebab dia mengantuk. Dia sudah bermancing. Ya, nanti beritahu dia. Siapa dengan Aizat? Kata orang berani nak jawab. Siapa dengan Aizat? Aizat. Muhammad Aizat Hazim. Tak ada ah?
Tak ada kot, tak ada.
Dia sedang memancing. Okay, continue ah. Itulah. Angkat tangan lepas tu saya tanya dia tak tahu orang pergi mana dah. Dia tak mahu dengar nanti nanti test dengan exam dia regrets. Okay? So these are the few properties that I think you all seldom come across. So like mechanical I think every subject almost every subject you have learned already, so I never touch. Okay? So thermal expansion, I think this is something new to you. Okay, so as I mentioned to you, right, thermal expansion, the one to measure is what we call CTE lah. Okay, what is CTE? I hope you still remember. This is the one lah. Okay, this is the one. Depan screen siapa yang mengantuk, lebih baik jangan mengantuk ya. Pasang telinga dengar. Okay, I think this is something new to you. So coefficient of thermal expansion lah. Normally they representing by CTE. So CTE normally for polymer, right? Must have CTE 1 and CTE 2 Okay. So this CTE 1 and this CTE 2, they have different value. Okay. Why one materials? For example, this is epoxy underfield. In this one materials, so one materials will have two CTE value, two different CTE value. So normally they label as CTE 1 and CTE 2, or they put the symbol alpha 1, okay, and alpha 2. Okay, you see different value. This one 50, this one 150 ppm per degree Celsius. So you see the value is much far different, right? Okay, why is it like this? Why is it like this? Because of this. Because of this. Okay, you see here. Okay, I explain to you what is X and Y. So you must remember what is X and Y. And you must remember what is this. What's the machine to run this? Thermal Mechanical Analyzer, TMA. If you give me this one, do you think it's correct or not? Do you think it's correct? No. Yes. Chinese say no. Yes. No. DMA will not help you to measure the thermal expansion. So, di sini ada berapa orang? 35. I assume semua orang buka telinga ya. Jangan mengantuk. Okay, buka telinga, dengar betul-betul. Supaya jangan kesal. DMA tak akan bagi kamu thermal expansion behavior. Okay. And this thermal expansion behavior other than thermal expansion behavior. This DMA actually will give you, not this one, remember, not this. Not DMA, but it's TMA, T. It's T, thermal, is not dynamic. D is dynamic. This is thermal mechanical analyzer. Okay, so I say one more time. This DMA will give you two properties. Okay, one is your thermal expansion. Thermal expansion measure what? Measure your CTE lah. Okay. Second information that this thermal mechanical analyzer that can give is CG. Gas transition temperature. Gas transition temperature. Okay, I hope you know what is gas transition temperature. Okay, okay. So this is something new to you. So I want you to listen carefully. This is important, yeah. I want you to listen carefully. So the unit will be ppm per degree Celsius. As I explained to you why they use ppm, because it's 10 to the power of -6, which is in micron size. Okay, micron. Okay, and you either give me ppm per degree Celsius, micron per degree Celsius, or 10 to a power of -6 per degree Celsius also is correct. Same. These three are same. Okay? This one, this one, and this one. This one, uh, 1, 2, 3 are the same. You give either one enough. Okay? Either one enough. These three are the same. Okay. So, first thing you see, thermal mechanical analyzer. So, thermal mechanical analyzer is also one of the thermal analysis, because it's using thermal. Okay, so maybe I explain to you how the machine look like, how the machine function. Okay, basically this is your sample. Okay, this is your sample. For example, your sample is rectangular. Okay, so this is your sample. So actually it's in a closed chamber. Closed chamber. Why closed chamber? Because you need temperature, just like DSC. But you don't see, if thermal analysis, most of the student give me what? DSC. I'm not confident enough to research DSC. Tapi baca soalan betul-betul, Baca soalan betul-betul. What is the question asking you? If the question asking you thermal enthalpy, list a thermal analysis to determine thermal enthalpy and also gas transition temperature. Yes, this is the SC is the one. Then you are correct. If the question asks you want to determine thermal expansion and gas transition temperature, then it's this one. It's this one. Okay? It's this one. Thermal expansion properties using PMA. Okay, back to the equipment. So it's a closed chamber. So this one it will close also. Okay? So this is closed all lah. Okay, the sample is inside the chamber lah. So it's like a furnace. Okay? So it's controlled temperature by the thermal copper lah. So the temperature range also is the same like you what you will do using the SC. You need to set a range, a temperature range. From room temperature up to 200 or from room temperature up to 150, this one you determine. Okay? So also what information you need to give? What are the information you need to give? Tak ada orang tanya saya. Macam mana nak key in? Di SC you key in what? Di SC you key in then heating rate and heating temperature, right? So this one you must key in the heating range also. Okay? You must key in the heating range also. Okay? Then later, what you need to have, you see lah, if you don't know, you really cannot remember, you just remember this graph. What is X? Temperature. It has a range, right? So temperature range lah. So you tulis lah berapa you nak. Okay? From 50 degrees Celsius to 200 degrees Celsius. For example. Okay. So sudah 2 markah. Kan? At least 1 marks lah. Okay. So if you can't remember, you see lah what is X. What is X? Length change. If measure the length change, which means what? This is your sample. Okay, I ask you if this is your sample, pure sample, of course need to pure sample, cannot be liquid lah. Liquid, how to measure the expansion rate? Correct or not? Okay, so I ask you, if this is your sample, if I increase the temperature, what will happen to the sample? What will happen to the sample? Expand, yeah. Yeah, Syah masuk. Okay. So for example lah, original both same. Okay. Before you heat up, sample like this, right? After you heat up, the sample expand, right? Expand. So where you measure this thing lah, this probe. This probe is can up and down. Okay, so you put a sensor here. So if this thing expand, let's say it's expand, so the probe will go up lah. So the sensor will measure. Okay, what is the difference? It will calculate lah the difference. Original here. Okay, original is here. Okay. After expanded here. So what is the differences? What's the differences? Differences will be here. Correct or not? These will be the differences. So changes. Length change. Length change. So after 50, change, increase. This is how the machine measure. Can follow or not? Up to here can follow. Who cannot follow? Put up your hand. Who cannot follow? Put up your hand. Tinggal 34. Who cannot follow? Put up your hand. Can, so I continue. Okay, so this will be your changes. Okay, second thing, you let me know what to measure. What you need to key in. If I want to measure this. So what I need to tell the machine? What I need to tell the machine? Anyone want to try? Second thing, I need to tell the machine about what?
Thickness.
Thickness, your sample thickness. Or the length. If it thickness or the length also can. Okay? This is the thing. Like instrument, you need to measure your sample thickness also, right? This one is the same also. Because you need to tell the machine what is this. So that it can measure. From this one, because the when you take away the sample, the plot starting 0 is here, right? So you need to tell the machine the 0 point starting from where? From here means your sample thickness. So it will start measure the difference here to here. Okay? So this length minus this one, then you get this one. You see or not? This one, the machine will get this one minus this height. They cut out with this one. So you will have length change. Okay? So you will have x, this one x. See, it's in micron, yeah? It's in micron, yeah? Okay? So length change. Okay? So these are the two most important one. Okay? Maybe the third one is you need to tell like DSC also what gas. Okay? The what gas you need to put in. Argon or you need nitrogen. Okay? Also can. So yeah, these are the most important parameter you need to tell the machine. Okay? You need to tell the machine. Okay? This is the parameter that you need to key in. Okay? So from here already 3 marks. Okay? So um so you must remember this graph. I let you know this graph is very important. So remember x is temperature, y is length change. Okay? So you must know what is the shape of the graph. Okay? No peak, Don't draw something like you have a peak like this. Oh, sorry, you're wrong. Not this, I don't want to see something like this, Okay? Not this. Is straight line, then go up, further up. Why further up? Okay, so you see here, intercept is your TG. Okay, so I let you know the TG that you got from DMA and the TG you got from DMA and the TG you got from DSC are different. They are not going to be the same, but the range will be almost there, but not exactly the same because different mode. Okay, different mode. Okay, so you can get TG intercept and the TG is here. So you draw a line down here. So this will be your TG lah. So maybe 120 degree Celsius. Okay? So this will be your TG. Okay? So this will be 112. Okay? You written here 112. Okay? 112. So It's here lah. Okay, so TG this is TG. Okay, how to measure your thermal expansion? How? You see there's a changes of length. Okay, what do you think? This is grassy stage, right? Before TG is what? Grassy, right? After TG is what? Rubbery, right? Okay, so you see CTE before TG is higher or CTE after TG is higher? After TG is higher. Why? Maybe I ask other people. Iswaria. Apa yang tak jawab ni? Iswaria. Iswaria. Tak ada. Why the TG after? Why the expansion CTE after the TG is higher? What do you think? What do you think? Or maybe Pawi here or not Pawi?
Yes, okay.
Why the TG after the CTE after TG is higher? What do you think?
Maybe because of the rubbery stage.
Yes, yes, exactly. Because it's in rubbery stage. So that's why we need to learn about grassy and rubbery. Why must have this TG? That's the function. Grassy, harder, right? Rubbery, softer. So as CTE expand more. Expansion rate is more. See, this one 50 only. This 50 micron per 1 degree Celsius. This one 150 micron per 1 degree Celsius. So properties before TG or after TG is better for underfill materials. Wait I call them. Shalini? Shalini? Shalini not here. Kitana? Kitana? Kitana also don't like. Shalini. You know what I asked just now or not? What was my question just now? Huh? What was my question just now? Time to time I will call you. Don't just open and run away.
Doctor, is it after TG?
Why after TG? For underfill. For underfill, we need higher CTE or lower CTE is better. For underfill, higher CTE is better or lower CTE is better? Lower CTE Iyasha bagus. Okay. Lower CTE. Okay. We need to lower CTE. So that's why TG need to be high. Okay, your TG need to be high. If not after TG, your CTE will be very high. Then the CTE mismatch will be very, very obvious. The CTE mismatch between your dye and your substrate. And your underfill material will be very, very, the differences will be very, very severe. Okay? So this is better. CTE one is better. For underfill material, CTE one is better. The lower, the better. Huh? You remember, CTE, So this one come back again. So you need to compare CTE or supplier 1 and supplier 2. Lower is better or higher is better? Now you know. Okay? Okay. So back to this one. Okay, what else? So must have CTE 1 and CTE 2 lah. Okay? So from this graph, actually, you see you can explain so many things. So another point, okay, if you want to have another 2 marks, normally formula I will give 2 marks. Another 2 marks will be your formula. Okay, so this will be your formula. Okay, so formula, this is, what is this? What is this? So alpha, what is alpha? What's alpha? What is alpha? CTE, right? Okay, so CTE equals to dl over dt. Wait this one. I want to show you first after you confuse. You remember this one enough? Easier. Okay, what is dl? What is dt? Okay, so this is straight line, right? Straight line, this one. Straight line, this one. Still remember what is this? What is this? Still remember or not? What is this? What is this? What is y? What is x? What is m? What is c? What is this? What is this? Y is y lah. X is x lah, doktor. Aduh. Macam ni pun tak tahu ke? M is what? Radians lah. C is what?
Slope,
Intercept
slope.
lah. Betul. M is slope. Okay. So dl per dt is what? dl per dt is what? What's L? Son. Son ni sudah.
Yeah.
Marah. Zone, what is dt? dl dt? What's this? How to get this one?
Is it gradient?
Yes. The slope. The slope. Okay. If you want to calculate alpha 1, means you take the slope here. How to measure the slopes? Still remember dy per dx. Means different in y value. Y2 minus y1 over x2 minus x1. Okay, so that is your slope. That one will only explain to you how to get. So you just remember this formula. Okay, so it's a slope. Okay, different in L. Y2 minus y1 is your different in L. dt is what? X2 minus x1. Okay, and you get your slope. So remember, you need to divide it by your original sample length. Where is your L naught? Where is your L naught? L naught where? This one, L naught. L naught, this one. Okay, so this one, your L naught. This one, your L naught. Okay, so you must divide it by your L naught. Then you can get your CTE. Okay, then you can get your CTE. Okay or not? Very simple, right? This formula is very simple. You remember the slope, then divided by your L naught. Don't write dl dt. Nanti you tulis macam ni pula. dl dt over 1 over L naught. That one wrong. No. Times 1 over L naught. Okay? Up to here, can understand or not? This not inside your lecture notes. Huh? If you want, you take a snap. I give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, time's up. Okay, we'll go to the next. Okay, so this one is another graph showing you how to measure lah. Sometimes it's not a very straight line. Sometimes it will have like a curve like this. Okay, if there's a curve like this, so you need to draw a straight line. You choose where will be the line. Okay, so this one, then if I want this one here, it's here very curved, right? So maybe you take here lah. Okay, so these two straight line, come across, this will be your DG lah. Okay, so expansion, okay, sometimes it's written like expansion, so must be in micron lah. This one must be temperature. Okay, so this will be your DG lah. This will be your DG lah. This is the example lah. So this is CTE below TG and this is above TG. Okay, so you see, sometimes they write CTE below TG. You need to be careful of CTE below TG and CTE above TG. Then sometimes they will say CTE before TG and CTE after TG. These two things, you need to be careful lah. So you must understand, then only you know where is it. CTE after TG, you put it here, okay, on case. Okay, this is CTE before TG and CTE after TG. So this is below TG. We will put this one CTE below TG here because below. No, this is above. Above TG, temperature is higher, is above. Lower, then it's below. Okay, here this temperature. Okay, so if you put this one, this one below TG here. On case. Wrong already, okay. So this is a higher level lah. Okay, if you know this formula, then you know what's written here. This is just like y1 minus y2, y2 minus y1, x2 minus x1, and this is L0. So this is below TG, so you take the region A to B. Okay, so after TG or above TG, you take the region C to D. So y2 minus y1, right? So yd minus yc lah. LD minus LC divided by TD. TD is the temperature. PD minus TC. So if you are confusing, just this one. Okay, just this one shall do. Okay. Okay, so you see the differences for most materials. Before TG or below TG must be lower lah. Okay, must be lower. If you have filler, normally is even lower, provided the filler that you use has lower CTE than your epoxy lah, than your underfill metric lah. Okay, so after TG is higher compared to lower TG, but the one without filler even higher compared to with filler. So if we need to construct a tangent line to a curve above and below, then we can get a DG using TNA. Okay, using TNA. Okay, up to now can understand or not? Can understand or not? So I think today I stop here because I'm afraid you will. Today I stop here lah. So any questions? Or you want to continue? We stop here, okay? Today we stop here. Eh? So do you have any questions? So you learned something new today, right? This one you never learned before, right? Yes or no? Or you already learned before? You learned before or not? Have you learned before? Previous. This one? This one? This one? This one, yes. It's not inside your slide, eh? Huh? It's not inside the slide, ah? Huh? Not inside, ah? Not inside your slide, ah, Jeff? Not inside the slide that I uploaded in e-learning, is it? Okay? Any questions before we end? Any question before we end? Nasri, your Thursday class, the 4:30 one is online or face to face? Susah hilang. Tak siapa ada class Thursday 4:30 eh? Class apa tu? Is face to face or online? This Thursday. Huh? Only Nasri is taking, is it? Later I ask him. So I post the link again. I can't get the QR code today. I don't know why. Open since 2 p.m. already. So I just post the link. Eh? So who hasn't signed in the attendance? Please sign in now. If you have signed in, then you can leave. If you hasn't signed in, you sign in now. I have posted the link inside the chat box. Okay, bye. Who hasn't? Allah.
Allah, sekejap je.
105 or 104?
104.
Oh, sekarang baru buka mic. Saya tanya tak mau buka mic pula.
Malu.
You malu? Orang
Okay,
boleh.
dah.
Doktor, yang ni
Tak
ada
boleh
tower
percaya.
test ah?
Nantilah. Test next week kan? Ramai nak test Thursday. Nantilah baru saya beritahu. You study dulu lah. Sudah? Sudah sign in ya? Sudah sign in, I drop lah. Hey. Sudah sign in ke? Kalau sign in boleh leave lah. Siapa tak leave ni? Siapa tak leave ni? Something wrong.